Hello, hello, hello. Welcome to Enlightning, where today we're going to talk about Sigstore. I have with me Zack Newman and Lewis Denham-Parry. Zack, tell us about yourself, please.
Hey, I'm so excited to be here. Thanks for having me. I'm a research scientist at ChainGuard, which is an amazing job where I basically get to think really, really hard about why we trust the software that we run on our computers. Spoiler, I guess the answer is usually we have no good reason, and that's what we're here to talk about today. Before this, I was a PhD student at MIT working on applied cryptography, and that's how I kind of got into the field. I was very interested in taking some of these techniques that get studied in the academic world but don't really get applied, and seeing can we use them to solve real problems. So that's what I like to do.
Amazing. What a cool job. And Lewis, tell us about yourself, please.
Where to start? Well, so hey everyone, I'm Lewis. I'm a solutions architect at ChainGuard. So today I'm working with our customers on enforce and images. A bit about my backstory. I was a developer. I was terrified of security for quite some time. And then I realized that actually security is this problem that we get to solve, and it's just constantly changing. So it's so much fun. And yeah, that's where I've ended up here today. And it's great that I get to share the company with Zack at ChainGuard, but equally I get to go around the world, go to conferences where I get to meet people like you, Whitney.
Amazing. Yes, so glad to have you here. I way back when I started, which I guess wasn't that long ago, like a year and a half ago, I used to host a show called Tanzu Tuesday that doesn't exist anymore. But Lewis was always one of my favorite guests, and we became friends back then. Y'all can unmute yourself. I don't know what's going on in the background of your each of your houses. I guess I don't want
I'm
to
in New
presume.
York City, so always safer to remain muted by default.
Let's, yeah, I trust you. I trust you. Except, I think everybody should follow Lewis and Zach on Twitter right now. What's going on? I think, are you all making a point about trust right now? That why would you even trust us to have the right Twitter addresses, the right name, the right anything that we're supplying
Yeah,
for you right now? Yeah.
yeah.
That's a
I
good
don't know
point.
why you. Yeah, I don't know why you've got my Twitter handle. Like this is ridiculous. It's just like
It is. It's rude. Rude of me. I want to say hi to some folks in chat. Hi to Lisa's here every week. Thank you so much for coming, Lisa. Hello to Hector. Thanks so much for being here. And hi, Simon. So glad to have you. Wonderful. So, I have a question for you, Zach. You say like deep thought is your job. How do you like deep thought doesn't come easily, right? You can't just like bam, I'm going to start thinking deeply now, right? You have to like ease into it. Is first of all, is that a correct assumption? And second of all, what's your strategy for
Yeah,
easing into
I would say I have a personality where I don't have a lot of other options. If someone gives me a problem to chew on and the answer seems simple, the first place my brain goes is, but is it though? Uh, it's all about just kind of examining the assumptions that you're working with, which I think in computer security specifically is a really useful skill. So many security problems happen when you come to the table making an assumption about
Mm-hmm.
no user would ever give me input that was this long, or no user would ever have a name that had weird binary noise in the middle of it. And when that assumption gets violated, things break, and a skilled attacker can use those assumptions and the fact that they're not true to kind of get around whatever it is that you're trying to do.
That I asked you a question about how you get into deep thought, and somehow you turned it into an answer about assumptions, which I love. I think thinking about security from a point of view of what assumptions are we making is a nice approach. I enjoy that very much. Lewis, I'm excited to see you at KubeCon. Are you speaking?
not this year. I didn't actually. It was the first time in a while I haven't submitted CFP, and
Mm-hmm.
but equally, I doubt I would have got accepted anyway this year. I've had some good luck recently, but no. But in all honesty, I'm super excited because I think there's an announcement this week where it's 10,000 people have signed up to go, which is
I
going to
heard
be
it's on track to sell out. That's wild. Yeah, that's
yeah.
cool.
And But it's kind of nice in a way because whenever I've got to talk, I'm so stressed. And I'm updating my slides constantly, and it's just always whirring in the background. But this year I get to go across and I get to enjoy it. So I'm going to be there. We've got a booth out there, so if anyone wants to hang out and come and chat, then I'll definitely be there. And yeah, I'm looking forward to some talks.
And we're making an assumption that you have to, by speaking at KubeCon, you have to speak officially. You could just stand on a chair at one of the after parties and talk really loudly and teach us all something, right?
Yeah, I'm really good at speaking, but not many people listen. So
then are you good at speaking?
Fun fact: I couldn't speak till I was 4 years old, and yeah. So someone else who was in that category was Einstein, but we decided to go our separate ways at 4.
So, Zach, we have a request in chat. Please say I didn't miss Zach's magic trick. Do you have a magic trick handy?
I can do the exact same one I did in the teaser video. I did notice that I look extremely stern and serious in that video, which was supposed to be fun, and it was because I was concentrating really hard on getting it right. Extra time at the end, I'll hunt down a pack of cards and see if I can remember the tricks from when I was 12.
Right. Oh, that was impressive that you've held on to that knowledge for such a long time, again, making assumptions. And then we have another, if we have time at the end, comment. I'd love to get your thoughts on Sam Altman putting the onus on an open API issue. I'm not sure what any of that's about, but maybe by the end of this.
And I would love to come back to that later on for sure. Okay,
let's all make a pact to try and remember to do that after. Yeah, get this man some cards is what I'm hearing in the chat. All right, I'm going to start moseying my way behind the light board. I would love to hear from chat about what is your experience with software supply chain security in general and with Sigstore specifically, and really maybe y'all can kind of give me some context while I'm moving about why I'm hearing so much buzz around software supply chain security. Why is that such an important topic right now?
Well, I'll jump in for a moment whilst people are frantically typing. And yeah, so I was up in Meetup in Manchester earlier this week, and I was talking about Salsa. So I'd like to share a link about Salsa as well, which is about supply chain security and the framework that we can put to it. And it's our security threats aren't just on the code level. It's the basis of where are we building our code. Like SolarWinds, if you've got the bingo card, I've mentioned SolarWinds now, so you can take that one off. And yeah, so it's important that we identify these vectors and how do we defend against them and what do we put in place there. So, and most of this for me, it comes down to trust and how do we build trust in what we have. But I guess, Zach, do you want to jump in on that?
Yeah, I think that's exactly the right point to make. I think trust is really the key word here. Because in some sense, software supply chain security is no different than any other kind of computer security. It is all about what happens when your assumptions are violated. You thought that, to go back to that example that we'll revisit later, some open source library that you were using did one thing and in fact it did another. And then that caused a leak of private information. Could also, be, you thought your build machine was building things correctly, and it turns out your build machine was compromised and hacked. And so, in some sense, all security is the same. But what really makes this problem different and interesting is it's about, trust. When you are getting your software from somewhere else, and that could be software you think you've written, that could be software someone else has written. Why do you think it is the right software? And I think that's why it's so hard and scary to go down this journey, is because the first step is to try to enumerate all of those trust assumptions that you've made when every time you type kube control apply, right? There are millions of lines of code that kind of go into that. And so once you start writing down what had to go right for that not to be malware that I just deployed, pretty quickly things get scary.
If you think of all the complexity that everything is built on top of, we're several levels up of Yeah, the millions of lines of code resonated with me. And then the trust and the assumptions are like two things that I have a feeling they're going to keep coming up, which is, yeah, really, I like that a lot. And another thing you said that kind of surprised me was like trusting your own thing that you built. Like that's maybe something that I didn't understand that needed an extra level of verification.
Right. And again, it goes back to, the word assume is really key here. Because, yeah, I assume if I publish something to my GitHub repository and then later, that gets built and deployed, what got built must have come from that GitHub repository, right? Because it says, it says my name on it. And that's exactly the point Lewis was trying to make, is just because something has a particular label, with the Twitter handle, just because something has a particular label doesn't mean it actually came from that person or that machine.
Excellent. All right.
At that point as well, but like and subscribe my channel, Wickety Whitney. That's where you'll find me online.
Across the board, pretty much, huh? All right, so those of you who are regular watchers of the show, I'm relatively new to tech, and what I love to start with is getting some context for what was the world like before Sigstore existed, and why did it need to get made?
Sure, I can go ahead and take a stab at that.
Okay.
The short answer, and this goes back to exactly the point about why I kind of left the academic world. Before Sigstore, we had a bunch of great technology that you could use to sort of verify the integrity of your software supply chain. And some of the technology is cryptographic, right? Digital signatures, and so on. Some of the technology was oriented towards software deployment systems, and nobody used it, right? And so this is in the open source world, right? We've supported digitally signed software packages on repositories like PyPI for well over a decade at this point. And the adoption you see by package maintainers is low single digits, right? And if nobody signs the packages, then I can't have a policy like I'm only going to use signed software, right? There's sort of a chicken and egg problem that we get into.
So fascinating. So it's not that it didn't exist, it's that the adoption was low. Absolutely.
And I mean, usability is such an important part of any technology. The prevailing sort of school of thought in the 1990s among crypto folks was extremely optimistic. It was, now that we have these algorithms, censorship is over, and we can have and you see some of this also checking off the buzzwords in the cryptocurrency world, this optimism about the supreme, the importance of the technology itself. And once the technology is in place to do something, adoption will naturally follow. But really, we found that getting folks to do the right thing means it has to be easy for them. It has to be convenient. It shouldn't cost them anything. And so usability, I think, was a missing ingredient from a lot of solutions for, in particular, digital signing, which is what we're going to be talking a lot about today.
Okay. Fuel Snowball has a comment, what, based on this comment, what security did exist?
Yeah.
So surely people were doing something, right?
I mean, the answer I would give to that is sort of, there's a lot of rhetoric around so-called zero trust. And again, we're going to take off all the buzzwords today.
Yeah.
The meaning of zero trust is quite interesting. It's this idea that whenever you get, it came mostly from the networking world. Whenever you get a network connection, you should not trust, that the data coming down that pipe is actually from who you think it is, because it came in on a particular port with a particular source IP address. Rather, you should try to use real, sort of authentication mechanisms to verify where that traffic is coming from. So old school, this is the hacker in the hoodie, typing frantically. and they shout, "I'm in." What are they in? They're behind, the firewall. And once they're behind the firewall, they have all of the privileges that anyone would ever want as an attacker. And sort of the cool way is no matter if you're already behind the firewall, because guess what? If you plug something into the wall in the office, you're behind the firewall. If you're a printer, you're behind the firewall. We're not gonna trust. We're gonna verify who you say you are and why you should be allowed to do something.
So pre-Sigstore, there was a lot of concern for getting traffic past the firewall, but maybe not a lot of concern once it was in.
Yeah, and firewall is not quite the right terminology to use, but I think it's in very analogous. So pre-Sigstore, you're deploying something to your Kubernetes cluster. Well, you type in, let me download, gcr.io or hub.docker.com/ubuntu:\latest. And because it's, coming from Docker Hub, it must be the image that I think it is. Right. And so that's kind of the world, is where you were sort of, without justification, you had to trust, you had to assume that what you asked for is what you got.
Okay. So before Sigstore, people weren't using security software, not period, but not fully, right? And then assumptions were being made that entities were, I'll just say assumptions were being made.
Yes.
And then Fuel Snobble said that they've heard this called onion layer security as opposed to hard shell. That's interesting. I like that, those mental images.
Yeah. I think that's a nice analogy, right? Where you really, you want defense in depth is sort of the term you would use if you were wearing a suit and pitching a military administrator on buying your company's product. But all the same idea, right? Is that, you want layers of security. You want to, whenever you are handed software and told to run it, you should be asking, why should I trust that this software is legitimate? Because one way to do that is to just hope that your connection to wherever you're getting it from is secure, and then hope that the place that you're getting it from is also secure, and hope that the processes that they used to build that image, right? It's hope.
Ooh, that's a lot. Yeah. Excellent. Okay. So tell me about Sigstore then, and how it helps to solve these problems.
Yeah. So I think Sigstore solves a pretty narrow but really important part of this problem. And the part of the problem that it does a really good job with is sort of assigning identity to sort of actors in a system. And that includes human actors. So I might trust some software because Whitney built it or because Lewis built it. But it also assigns identity to machines. So I might trust this binary because it was built on Circle CI or Travis CI or GitHub Actions, right? And so prior to Sigstore, what we would do is, we would have cryptographic key material. I would generate a key pair, so-called, and I would publish the public half of that key pair, and then you'd have to somehow get my key, know that it belongs to me. I would have to keep the secret half really protected. Maybe it's in like a hardware security module, but like everything really does hinge then on that key. And so when you have that, if you can sort of, now you can say who's who, because only Zach has Zach's public key. And trust, if I sign a message, you can say, cryptographically, I am confident that that message was signed by Zach, because Zach is the only person who holds that key. But that requires solving two really, really hard problems. One is sort of key distribution. How do I get your key in the first place? And a lot of early cryptographic systems worked based on a philosophy called web of trust, where I'll get a key off the internet, and then, it turns out, Whitney, I get Whitney's key. Whitney knows Lewis and I know Lewis. So then transitively, I can start to trust that, this key does in fact belong to Whitney. And this was kind of okay for like emailing, friends and so on. But what are the odds that I, as a developer, like know somebody who works on NumPy? And even if I personally happen to, that's extremely, isolating and really high barrier to entry for trust. And so we don't want to build trust off of these social networks. So we're going to experiment with alternate ways of doing key distribution. And we'll come back to what those might be. The other part of that problem that's really hard is key management. And so we expect availability. I'm an open source maintainer. I have some software package I publish on NPM or PyPI, and my laptop hard drive crashes. If my private key was on there, I'm toast, right? We're out of luck. There's nothing I can do to continue publishing software signed with that key. So if we're requiring signatures from what I'll term a traditional, public-private key pair, a long-lived public-private key pair, and anything bad happens, we're in a whole lot of trouble.
Yeah. So, well, first of all, Fulcio has a comment. I trust all software because I want to be able to close the ticket and go home, which is like exactly the point you were saying at the beginning. Like people aren't going to, just because it exists, people aren't going to use it unless it's easy.
Absolutely. And so like, that's the thing is like, it doesn't just need to be easy. It needs to be the default, right? And like without thinking about it. And, if I'm a developer and I'm just trying to get my job done, I shouldn't have to think about security. That's someone else's job. And so if you set up infrastructure appropriately, and this is a dream, right? It's kind of far off. I'm sure most developers and other folks listening have had an incident where they just wanted to do something really simple and the security team put their foot down and said no. And I urge you to respect them for that, because they really are doing what they have to keep things safe. But the best security technologies are ones that we can roll out and it's seamless. Nobody has to change, especially on the consumer end. Nobody has to change anything about how they're downloading and the software. The sort of cryptographic verification and policy enforcement will just come for free. And that's the world that we're working towards.
And Lewis said up top, he used to be a developer and he was afraid of security, which is different than just like it not being easy. Just like, what if I get it wrong? Yeah.
Absolutely. And I think that's pervasive and kind of for good reason. So well-intentioned security folks, a couple decades back, really started spreading this idea that security is hard and you shouldn't try to do it yourself because you need special training. You need to be one of these security engineers. And I don't even totally disagree with that, right? There are so many subtle things that can go wrong in the security world that you really are always best off by sort of consulting with an expert and thinking through, because they're gonna point something out that you've never in your life thought of. But at the same time, that attitude makes it so hard for everyone else, which is most of the people in the world, to adopt these security technologies. And I think that sort of like elitism led to, kind of decades of the tools for cryptographic signing being extremely hard to use.
Oh, yeah, that makes sense.
Yeah. Sorry.
Yeah. Fulcio was saying it's difficult if you're in a company like a startup where you don't have enough money to hire security engineers. That's a good point too.
Absolutely. And so are we just kind of leaving those folks behind? We love companies like that. We want them not to get hacked too. And so the open source world step in and provide some tools. I can't promise you a silver bullet, but to solve some part of the security problem, to bake that into the dev tools that you're using anyway. And so your stack just gets a little bit more secure, basically for free.
So,
if I could jump in on that point as well, just to say, because this has resonated with my career so far in that as a developer, it was a security team. I would say I need to use this library. I had to go to the security team. They'd have to audit it. They'd have to say that they're happy with it, and then we'd be able to proceed. And that was usually a barrier to entry, which it prevented us from building what our unique selling point was for a company. And usually you need to build those things to be able to make money and have a company and so forth. And so it was never that fun. And again, for me, it was that basis of thinking of security. I preferred at that time in my life to just have a well-defined sprint, say, I'm going to deliver this in 2 weeks, where security, it was like that line kept changing. I did not know where that line was. And it's that Friday feeling. I just wanted to close the lid and enjoy my life and not think, oh, I'm about to get owned right now. So, so those were the bases of it. And it's a case of, and I think it's important now that with the tooling that we have, and it's the basis of parts of my career, I've now focused on using tool sets that are really good. So I use Git as an example. I feel I'm going to be using Git for quite some time, so it's quite a good time of my investment to get that in there. Now, with tools that we're starting to see with Sigstore and such, these are the tools that I feel are going to be consistent with security as well. And so to that question about if you don't have enough money to hire the security engineers and so forth, I definitely look towards Salsa, salsa.dev, because it's a leveled framework approach. And that's the thing, security is this big word. And again, you might feel that it's scary, like earlier on in my life, that was a big scary word. But when you look at it, these are just like the best practices of being a developer anyway. It's like if I follow these standards and these practices, I'm starting to get myself a bit more secure. And I would compare this as well to documentation. It's a case of if you've got an idea, that's great. But until you put it down on writing, and when you start to share that, that's when you start making a difference. So with security, again, it shouldn't be an afterthought. It shouldn't be something that you're thinking about. If you make an attempt at it, and then whether you're right or wrong, at least you're starting on that basis to then, because you're going to be more secure by starting than not at all.
And sometimes it's easier to incorporate it from the ground up too than try to add later. Lewis, if you want to put that link in the private chat, I can transfer it over to the chat that everyone sees. So to recap, I have a feeling we're just barely tip of the iceberg here. But so far, Sigstore assigns identity to actors in the system. So that includes both people and processes. And so far, that assists with key distribution and key management. And when we say keys, we're talking about like the private key infrastructure keys. Yes.
Yeah.
Cool. So keep building the story, please. Hello, Armando. Thanks for coming.
Yeah. And so this isn't just, my opinion, right? Going back to trust, why should you trust me? Just because I'm grumpy about, a particular set of tools doesn't mean that they're not any good. But there is actually a pretty rich vein of, academic research on, so-called usable security. And there's a bunch of papers. The first one was called "Why Johnny Can't Encrypt," and then a couple of years, and that was basically looking at some of these tools that you used for encryption in digital signatures, and just watching people, experts, right, nominal experts. They went around, the graduate students at a computer, cutting edge computer science laboratory, and they said, try to use this security tool. And they watched people flail, and then they wrote up, and they said something's got to change. And then you come back a decade later, and someone writes a paper called "Why Johnny Still Can't Encrypt," and you come back 5 years after that, and there's "Why Johnny Still Can't Encrypt." And so there's a whole bunch of backing for this idea that something is hard about the scheme that we've set up for digital identities and digital signatures. And that's what we're trying to make a little bit easier. And so I could complain all day. Maybe now's a good time to move on to, okay, what do you do about it?
Yeah. I'm putting a problem. Security is hard sometimes. Okay. So do you think this is like the bulk of what Sigstore does is identity, providing those identities, and then we'll get into how that shakes out in actual practice?
Yeah, there's one more bullet point I'd like to add, which is the sort of the logistics of managing and distributing signatures. Because there's a big difference in developer experience between, let's go to container registries in particular. If I want to sign a container image, one command to sign the image, and then stick that digital signature right next to that container image so other people can find it, versus it produces a file on my machine, and now I have to figure out how to get that file to everyone who could possibly be verifying it. And so yeah, the logistics are a big part of the usability, and something that doesn't attract any interest at all from the academic community, because it's not an interesting research question of how to move a file from point A to point B.
So when you're saying signatures here, you're meaning a container image signature, not like a CA signing a private.
These are,
public.
yeah, I mean, these
Yeah.
are the same exact, underlying technology. So in some sense, the answer to your question is yes, that's the kind of signature I have in mind. But in some other sense, there's not really much of a difference.
What should I write on the board? I just feel like if I was, I am pretty new to this, and the word signatures means more than one thing to me.
Yeah. So
and I'd like to be more clear.
Let's ask that question. What do I mean when I sign, for instance, a container? Like sort of the semantics question is a really, really interesting one. And it's a really common impulse to say, oh, like, I don't know if I trust this container. If it's signed, then it must be secure. And that's not necessarily a useful way of looking at the problem, because if I go and I type a command using Sigstore to sign a container image, does that mean that I like hex dumped the file, the like layers of the container image and looked at every byte on my own? I'm making some assumption about like what was in that binary blob when I'm signing it. And so signatures on their own don't really mean anything other than the person who owns the private key chose to create a signature on this, byte stream, this binary data. And then it's what we do with the signatures that imbue them with meaning. So in the example of CAs and signatures there, if I go to example.com in my browser, example.com has a certificate. What's a certificate? You can think of it as a little note that says name example.com, public key, and then they share the key of example.com. And then why should you trust that certificate? Well, that certificate is signed by a certificate authority. And this can go many layers deep, but eventually back to a small number of parties who we basically trust to verify identities on the internet.
Oh, so I didn't understand before right now that signing a container image is related to PKI infrastructure and publicly and privately trusted certificate authorities. Cool.
Yeah, the same underlying cryptographic technology used for signing both.
Cool. Will you help me with what words I should write here to what does it mean to sign a container image? A succinct way to capture what you just said.
I would definitely make sure to include the word, semantics. And then maybe another nice word to include there is an attestation. So what do I mean by an attestation? Rather than signing, think of it as like you're writing a letter. If I just wrote you a letter and I said, open SSL, and then I said, signed Zach, and I put my, signature on that, and I got it notarized, and I handed it to you. What are you to do with that? But if I put my on the letter, I said, I looked at the source code for OpenSSL and I didn't find anything bad with it, and then I signed my name on that. That's much more meaningful. And so that's kind of what an attestation is. It's a claim about usually a digital artifact and often signed by a particular party. From the comments, semantics is just a very hoity-toity word for like meaning. Like, what's the meaning of a signature? And so thinking hard about what the meaning of a signature is a big part of trying to design a secure software supply chain.
So a container image signature is an attestation.
Usually what you want to do is you want to formulate your container image signatures as an attestation. And so I'll give you a really concrete example. I might have my, I get it now. I might have my build service build my images for me and then sign an attestation that says, I took this source code. I'm not going to promise you anything about whether that source code is, for an app that's going to cure cancer or for its malware that's going to steal all your credit cards. But I took this source code and I built it. And so that's an example of an attestation that you could use. Another example of an attestation might be you make an attestation on the source itself that says, I audited this source code, or I am a maintainer on this project, and I know that this commit is a good one to make a release from. And so when we do attestations, we're saying something about a particular digital artifact.
So I can make this a little light for a moment because I've been trying to work on a new analogy for this. And the one I most recently tested out was with Batman movies. So hear me out. The origin story is always the same with Batman. It's always the same. But in my attestations, I trust Christopher Nolan because that is, for me, Christopher Nolan's going to do a good job with this source material and build it right. And so I think for me, that's what signing, and it doesn't have to be a container image either. It's whatever digital artifact it is. It's this way of we're testing to say that this is from us. This is who's doing it. And like usually I'd use a food analogy as well of if you're going to a restaurant for a meal, you don't necessarily, unless you're on the chef's table, you don't get to see the whole process. You don't get to see where the ingredients come from. You didn't see them growing in the ground. You didn't see them chopping up 8 hours before you got to the restaurant. You didn't see the state of the kitchen. But there's lots of trust built into that. And you might have trust because it might have a 5-star rating for cleanliness or a government official. That's where I'm building up trust and so forth. And so with this signing is a way that we can start to identify this. And I'd also say, because we got security is hard written there. And again, like for me, that's something which I try not to agree with because, and I think this is, as I've learned in life, most things in life are hard, but it's a case of if you work hard, add hard things, then they become a bit easier. The thing that we can't necessarily control is trust though, because trust is implicit. Like I trust you, Whitney, because I've gotten to know you. But then if something goes wrong, then I lose that trust. And so I think this is where we have to work harder at this now. And this is why it's so important, because we're putting something in place here, trust, to say you can trust this image, your critical infrastructure, your livelihood. You can trust us because we follow these guidelines. So I think that's where I'm getting to with this.
Great. That a digital is an attestation that adds some degree of trust. Like you're so careful to not say that it makes this digital artifact objectively trustworthy, which I appreciate.
I would just make sure to use the word claim, like making a claim about something.
Love it.
The word we usually use for that something is the subject of the attestation.
If I may as well, whilst you do that. Oh, sorry, I'll let you two finish first.
A claim about the trustworthiness of the digital artifact?
Could be a claim about anything, I could be a claim. I like this, but yeah, typically about the trustworthiness.
Okay.
So,
yes.
Zach, if you could keep me honest on this bit, then if I go back to the kitchen for a moment, because the other thing that we have, and it's something that you might start to hear a bit more of, is provenance. And with provenance, if you feel like you should have heard this word before, but then you don't know what it means, just remember origin. It's all about the origin of something. So with attestations, the way I think of provenance is the recipe. So it's a way that we're building it step for step, like our builds. That's where we see that. Attestations for me would be the saucepan that was used. Was it used on a gas hob? Who was the identity? Was there a chef here? Would you agree with that analogy, Zach?
Yeah, I think so. I think so. And then while we're nitpicking that definition, the definition you're giving is almost more for an attestation than for a signature. And so then the attestation is going to be signed. So I might rephrase that, basically just say an attestation makes a claim about a digital artifact and is signed or something. I think you
And-
just kill the first line and you're in really good shape.
This is comical, but also necessary, I think.
Yeah,
And
yeah, and security
okay.
people are annoyingly pedantic, but I think that's
Yeah.
what makes us good at our jobs.
Have you heard of the 4 agreements? Do you know the 4 agreements? I basically try to live my life with this moral code called the 4 agreements, and it's the first one is, well, it's don't make assumptions is one of them. So in life in general, I try hard not to make any assumptions. So I appreciate everything that's going on here. But it's, yeah, I'm not sure it's an interesting show, but I think we're going to produce a great result here. So an attestation makes a claim about the digital artifact, and then the signature signs the attestation.
Yeah.
So for people who've got their bingo cards ready for the next word, but this is where standing on the shoulders of giants comes in, because this is lots of problems and as Zach mentioned with the paper earlier on, this is complex, and when there's a complex issue to solve, then there's complexity built with that. But that's where Sigstore is starting to come in, because for me, that's where I started with this. Essentially, it was from that end user. So we're telling you all these problems, and it's all this is how big it is. But then, and this isn't, and again, next one for buzzword bingo, shift left. This isn't about putting it onto someone else. This isn't having to go on to a training course for so long to completely understand every aspect of this. This is how we can build it in. And so maybe now if we push on with that, then hopefully these things, they're easy, or I've got to be careful with words, but you can set them up, and then in a way, it helps draw this, and it helps solve all these problems that we're identifying.
I like that. So because this is, complex, then it makes it easy. We're talking about the developer experience, making it easy to get the tickets closed, but still.
Yeah. It's not easy to get the tickets closed. It's being confident to close those tickets as well. It's this basis of, I can easily close a ticket by clicking a button, but then I can't easily go to sleep. And so I'm a big fan of sleep. And so that's what I want to build up here is that I want to get it to this position where I can sleep well, knowing that we're putting our best defenses up. Because if I may as well, on the other side of this, when people are looking for the parts of where we're missing these points, sorry for using your term as the attacker, or as a red team in this instance, if someone's looking to get into it, it's not too much of a concern there. It's a case of, I like to compare that to a dog in a garden with a fence. It's a basis of, if I got a fence around there, the dog's just looking for a small hole to get into. As a defender, I need to make sure that all the fence is rigid and uptight, and that's a lot of effort to do. But we need to put these things in place to be able to build this up for ourselves. And so again, that's why we're not solving all of security here, but this is giving us from the source, from the provenance, from the origin, that's given us confidence to know what we're building from. And that's why I feel that it's as important as it is.
I love it. I love your analogies. And we're getting some analogy love in the chat too.
Cool. I'll be here for another hour.
And John's saying this is absolutely interesting, informative, and entertaining. Thank you, John, for validating us. All right. So I'm going to make sure we got the Sigstore definition correct, because everything builds on that origin, right? I'm going to sign it. Sigstore assigns identity to actors in a system. And so that's both people and processes. And that assists with key distribution, key management, and then the logistics of managing and distributing signatures.
Yeah, I think that's a nice succinct summary of kind of, what it does. And I'm very proud of myself for not getting into how it does it, which is kind of the curse you often get into when you're trying to explain a system with a bunch of moving parts. But yeah, I think that's
which, now that we have this down, you're welcome to go into the how, but we just wanted the end at the beginning, and now let's work our way up to it.
Yeah. Then let's do that. Let's get into the how. So like I said, managing digital keys is a pain, right? You're supposed to have kind of a top level root key that lives, on trusted hardware in like a safe deposit box somewhere. And then you take that and you have sub keys, and you have to have those. And again, they shouldn't live on your laptop. People often do put them on your laptop. So if any of these get exposed, we got to worry about that. And managing these keys is a pain. And like, if we had a physical audience, this is the point at which I'd usually say, all right, raise your hand if you have PGP signing and encryption key somewhere in the ether. Like you've made one and you don't know where it is. It's in, maybe it's in the basement of your house on an old hard drive. Right? And developers are, as a rule, not obviously some people do a very good job of this, but for the most part, pretty bad at managing keys, just because, that's not what we do as humans is pay attention to these like little things that live on a thumb drive. People are pretty good at keeping their digital identity secure, though. But we do have a number of quite good systems in place to keep like your Google email account secure, your GitHub account secure. And speaking for myself, if somebody got into my Gmail account, and we try to make that hard to do with two-factor authentication and things like that. If they got into my Gmail account and they wanted to ruin my life, it would take them 15 seconds, right? And so developers are pretty good at managing that kind of digital identity. And so the insight behind Sigstore is, can we turn the digital identities that people already manage, can we take those and use them for long-lived digital signatures?
Okay, love it.
Yep. And so the way that we're going to do that is basically I have to convince Sigstore that I am, Zach@gmail.com. Once I've done that, Sigstore will issue me one of those certificates I thought about, or that we were just talking about, that says, this is Zach@google.com, sincerely, Sigstore, right? And I can take that and I can go sign something, and then I can take that signature and that certificate and hand it to someone else and convince them that I am, in fact, or rather that the person that signed the artifact was me, at least if you're going to trust Sigstore.
Okay. So basically, you're using systems that are already in place. And Gmail's one of those systems?
Yeah. Yep. And the way we do that is there's authentication protocols, like standard. So if you click, log in with Facebook into a web app, exact same trick. That convinces that web app that you control a particular identity on Facebook. You can do log in with Gmail, log in with, a large number of identity providers support the protocols like this. And which ones are supported today is kind of an accident, so we won't go too much into detail. But in theory, you could add basically any digital identity provider to that.
Okay.
So at this point as well, I'll just say, again, back in my developer past, I once made my own authentication server. And again, if you want to lose sleep, just do that. And it's this basis, like Zach was saying, because it is ingrained to us day to day, is that I've got a number of things hosted on my Google account. And so for me, that's my point of trust. I trust Google and their security at this level. I've got multi-factor authentication set up on my Google account. I've got alerts whenever I sign in on a new device. So naturally, I'm built up that security for myself. And so then we're also using that in this process as well. Standing on the shoulders of giants, we've already done it, but you can take again, just in case you've only just joined into our bingo lingo game.
So, for example, Zach or Lewis or any of us can get a Sigstore signature or certificate, or it's the same thing. Can we? Oh, do we use those interchangeably?
Yeah, I would say use Sigstore to sign something with my identity.
Well, okay.
I can get. So you can say Sigstore certificate. Sigstore certificate is perfectly fine. Yep.
Okay. By authenticating with Gmail.
Yeah.
For example, right?
For example, yep.
And just to show, it could also be your GitHub account, for instance.
Okay.
And it was this week, just before I gave the talk, I had an email notification from GitHub to say that they're enforcing multi-factor
2FA.
authentication as
Yeah, I've
of,
been
yeah,
doing it.
to again, bingo. I think and they're doing it on a date which doesn't mean anything to anyone within tech on May the 4th. So I don't think anyone will remember the date when that happens. But it just shows again. It shows this basis again where this is an expected standard. This is what I would expect as a developer nowadays. This isn't necessarily just security. This is what I'm expecting. And so having this in place, 80-20 principle, like this mitigates a number of the attack surfaces that you can have just by having multi-factor authentication in place. And again, so we're building up on top of that at this stage.
Cool. So this is what it is, and then it happens by using already existing digital identity providers. Yeah. And we have some David Michael at some point agreed with something that one of us said. Thank you, David Michael. Sorry, I didn't catch it in the moment.
Cheers, David.
And then Salman, thank you so much. I'm so glad you're here, Salman. All right. Great. So that's a little bit of the how. Teach me some more, please.
Yeah, absolutely. So one point I do want to make too is, I think the example is most relatable if I, in this example, am a human, because I am a human, and I think most of the folks listening to this stream are also human. But you can do the same thing if you're a machine, right? And so this is kind of how we get into it with, we talk about like GitHub Actions build jobs. And so you can use the same sort of authentication techniques, and you can use Sigstore to get a certificate that says, instead of saying Zach signed this, it now says a GitHub Actions build job running with this configuration built. And so what sorry?
I'm oversimplifying greatly just by saying GitHub Actions can get a Sigstore certificate. Okay, great.
Yep.
Cool.
And that's really useful for having basically sort of CI/CD systems or other things like that make claims, right? Because what does it mean for GitHub Actions to say something? Well, GitHub Actions is a system, and they can basically promise, I was running this workload. And so if like for instance, if that a software package was built in JavaScript, let's say, using npm build, if that's a real command, you can, and that's the only thing that ran, and what source was the input to that. Now you can be pretty confident that the package actually matches the thing that was on GitHub, right? Because otherwise there's this hack I can do where I have my beautiful, github.com/leftpad library, and that's developed in the open, and we have 2-party review. We follow all the best practices. And then I can just git clone that. I can replace the library that was developed in the open with a Bitcoin miner or some other malware, and then I can run npm publish. And if I do that, the thing on npm does not match the thing in the public location that people think they're getting. But if you have, if you require that like GitHub Actions or CircleCI or another one of these builders build an artifact using a standard recipe, you can prevent that from.
Okay, so GitHub Actions can get a Sigstore certificate, and they might need to verify by using a predefined recipe.
Yeah. The certificate will identify what's running. Maybe identifying the workload or something like that.
Okay. Can get a Sigstore certificate, which might require identifying the workload, right?
The certificate identifies the workload.
Okay.
Yeah.
Great. Thanks. Which identifies. And that's optional, though.
Yeah, but if you don't have it, all you know is that
point?
something ran on GitHub Actions, which isn't that useful.
Okay.
So you want to know what ran. You want to know who ran it and what they ran.
Cool.
And maybe at this point as well, just to reference, because this is leading us towards automation as well. We want to automate as much as possible so that when we're building, it's in a clean, ephemeral environment, and then that gives us confidence in that we can, like the North Star within Salsa, which I mentioned earlier on, is reproducible builds for bit, byte for byte, which this allows. But equally, when you're getting started with Sigstore, I remember doing Sigstore the bash way, and then there's breakdowns at each point, and then it shows you how to do these things. But again, if we start doing that, buzzword again, drift. Like with VMs and containers, we didn't like having drift previously. We didn't like it, but if we created a VM, we had to SSH on to add this package and so forth. We want ephemeral environments. So again, we want this automation here.
So is it enough to just be like automation's important, or do we want to dig in on the idea of automation a little more?
I think for now, let's table that, and we can come back to how do you use this later on.
Okay.
And that will really get it deeply into that idea of automation. Does that make sense, Lewis, to you?
Yeah, sorry. I just, in talking of attacks, my daughter just walked into the room, so I will nod and agree, and we just got through this one together. Thank you.
I also forgot to close the door, so my cat might make a cameo. So we'll see. I have not secured against felines. Great. So where do you want to take it next?
Yeah. So I did a trick earlier, right, where I said you get a certificate. In that certificate is a public key. Where does that key come from is something I kind of hand waved over. And so that's worth exploring, because if you already had a key pair, right, that's the problem we were just talking about. You probably don't, and managing an existing key pair is a pain. So how can you put a key in that certificate? And the answer is you make a disposable one. You make a one-time use. I think the again, the hoity-toity fancy word you would typically use is ephemeral, but you make an ephemeral key pair. And then you stick the public key in that certificate that Sigstore is going to sign. And then you hold on to the private key just for a minute while you make, usually just one signature with it. And then you can throw that private key away. And guess what? You don't have to manage it, right? If I don't know, not that I encourage this, you should use a reusable water bottle, but if like me, you carry a water bottle with you everywhere, you worry a lot about losing it, right? And so if instead you just, every time you're thirsty, buy a plastic water bottle and throw it away, you don't have to worry about losing it. It's worth the effort, in my opinion, to bring the reusable water bottle. Saves you lots of money and you generate a bunch of plastic waste. But that's what we're doing with keys, and keys are free. Bits are free, basically, to an approximation. So these disposable certificates are really useful. Sorry?
Wow. So all that matters is that Sigstore, we trust Sigstore to have created a good one, and it doesn't.
Yeah. Strictly speaking, you, the client, are going to create that key pair. Sigstore never sees your private key. Okay. And then you hand the public key to Sigstore.
Okay.
It basically signs off on that public key and says, "Yep, this belongs to Whitney." And then once you've got that certificate, you can use the private key that you have, sign something, and hand them the thing that you signed, the certificate, and the signature, and someone will be convinced. Asterisk, and we'll revisit. There's one more step, but someone will be convinced that Whitney signed this thing.
But then you can't verify it if you don't have the public key, right?
Well, the public key is inside the certificate. So if I hand you sorry?
Yeah, I'm sorry. I'm trying to understand. I'll let you talk.
Yeah. So I hand you the thing that I signed. So that's usually in our example, the letter about OpenSSL that I wrote to you. The digital signature on that letter, and then the certificate, which includes the public key and it also includes the identity of the signer. And the certificate itself, you're going to trust that because you trust Sigstore. So the verification procedure looks kind of like, take that certificate, make sure that Sigstore actually signed it. Once you've done that, you can trust it. So you say, okay, Sigstore says that this public key belongs to Lewis. And then I will, and then I can verify the digital signature on that artifact or that attestation against that public key from the certificate. And if that checks out, then I can be pretty confident that Lewis at gmail.com or whatever the digital identity is that we're using actually made that signature.
Okay. So it basically transfers the trust that I had in the private key infrastructure, and it's making it so I have that trust in Sigstore instead.
It is kind of like its own private key infrastructure, which is tooling for doing exactly what you just said, for taking trust in some infrastructure or some service or like a small number of parties and turning that into trust for a lot of different digital identities.
Cool. So it doesn't limit the ability to still have two-way communication with the entity I've established trust with. Instead, it's channeling some of the trust through Sigstore that's managing some of the middle pieces.
Right. So yeah, exactly.
Okay.
So we already have really good with warts, but pretty good public key infrastructure for browsing the web. Right, you're watching this on Twitch or YouTube. Your computer doesn't come pre-bundled with the identity of YouTube. But if you type youtube.com, what you're going to get back from YouTube is going to include a certificate that says, I'm somebody that you trust, a certificate authority, which that your computer comes pre-bundled with. But the certificate authority says, anyone who shows you something signed by this public key is youtube.com. We're now doing the same thing, but for like your Gmail address or some other digital identity. So, yeah.
So you're like the equivalent of a trusted public CA.
Yes, exactly.
That comes bundled in a trust store in an operating system.
Exactly. And so the component of Sigstore that does this, that issues the certificates, it's called Fulcio, is the name you might have heard, or Fulcio. There's no canonical pronunciation as far as I know. Fulcio. And so Fulcio is the certificate authority, the CA in Sigstore.
Okay.
So I've also shared a link in the private chat, so if you could share it with me when you get a moment.
Absolutely.
So it's a blog post titled "A New Kind of Trust Route," which shows the key signing ceremony that took place, which is essentially where this trust is coming from. And it's a case of, just to reiterate as well, when you have a public key, that allows you to decrypt and only decrypt. It doesn't allow you to encrypt. And so that's why private keys are important, because we can encrypt with them. And that's what allows our trust. And to finish up with Zach's point as well, that's why ephemeral is to reference Batman again, even though he didn't necessarily have superpower, but that is our superpower of being ephemeral. It's this basis of, if you've got a long-lived key, then the longer that it lives, the more likely it's going to get owned. And so if you've got ephemeral keys that we only use once and then we throw them away, and they're only used to sign one thing, if that key did get owned, it's only going to own one thing. And equally, these keys are so short-lived, there is such a reduced attack vector on this. So again, I might be going a bit too deep now, but again, this is where it's huge, because we're getting so much from what we've learned previously in tech, and this is all just getting baked in. So this is all so easy to consume now.
So that's wonderful, and I'm glad you brought up again the ephemeral part, because I wasn't including that in my mental model. So every time two things want to communicate, Sigstore sits in the middle. Every time they're communicating, a new key pair gets made and verified and discarded over and over again.
You kind of, but what's interesting and different about communication in like a software supply chain is that typically the way it works is not that I'm talking to you live and sending you the bits of my, container image, right, synchronously, but rather I'll create the container image, make a signature on that container image. I'll go away. I'll go on vacation or retire or whatever. You might still want to verify that container image much later. And Lewis might also want to verify that container image. So the fact that this is happening not at a point in time, but rather, one after the other, that's I think makes it so that the existing public key infrastructure that we have isn't a very good fit.
Yes, for the long-lived reason that Lewis was just saying.
So it's a funny thing. A short-lived key for a long-lived artifact is kind of a weird paradox, but that's what we have.
I like it though. The Fulcio, the CA and Sigstore. Should we say more about it? That it's different. Like it's publicly trusted. Is it bundled? This isn't browser based, so it's probably not.
No,
part of that.
It's going to be. So when I said bundle, the CA root bundle is bundled with your computer. That's kind of true, but more often it's bundled with your browser. So when you download Chrome or Firefox for the first time, that's going to come with a little bundle of things to trust baked into it. And that's how we do it in Sigstore as well. Typically, you're going to bake the sort of root of trust for Sigstore into the Sigstore binary, which I think makes actually a good bit of sense, because if someone was able to compromise the tool that you're using to verify signatures, it's already game over, right? If you're asking this tool, are you verified? You don't need to worry about someone backdooring their own trust root in there. You need to worry about someone replacing that tool with something that always just outputs yes.
Yeah.
So you need to take that leap of faith and and sort of accept the trust root at some point. And so that's how we do it. So we bundle the root certificate for Fulcio with inside of basically the Sigstore tooling that you're going to download.
So the communication that needs to happen with Sigstore is only ever related to verifying digital artifacts. Is that true? Or is that, so it is kind of it's like something gets made to verify the artifact, and then that's it. Like there's not going to be two-way communication or
So yeah, I'm going to produce an artifact. I'm going to sign it. Part of that signing involves me authenticating with Sigstore. So I have to click login with, Google or whatever button. I get the certificate. I sign the artifact, and then I can publish that however I want. Maybe I stick it in my container registry.
Then it's the artifact is verified by Sigstore using PKI infrastructure, and then me as a consumer, I can say I trust Sigstore and they've verified, and I'm not actually looking at any PKI stuff myself.
Almost, because what you've learned is not that Sigstore thinks this, container image is safe. What you've learned is that Zach said the container image is safe, and Sigstore basically signed off on that statement. Okay.
I want to draw a picture of this. I feel like we're kind of beating a dead horse at this point, but I also feel like this seems to be a very important concept in Sigstore and maybe worth being crystal clear about.
Absolutely.
So, or maybe it's just like it needs to be more linear or both. So we have, Zach, this is Zach, very, very accurate. Zach makes a container image and wants it to be signed, right? And this would happen automatically, right?
Right.
And and then Sigstore signs the container image.
So the actual diagram says, okay, I've got the container image. Now what I'm going to do is I'm going to prepare my letter, and my letter says, dear
Ron,
dear whoever.
It's not Sigstore, dear future consumer.
Yeah, exactly.
Okay. Dear future consumer. Okay. And
I
then
might.
what?
Yeah.
Could I try another analogy just for a moment?
Yes.
I'm gonna. So when you purchase something from a store, you get a receipt, and the item that I purchase, it states that I purchased, say, this bun, and there's my receipt for it, and it says at this moment in time I did this transaction, and there's my receipt for it. It doesn't necessarily state that the bun was fresh or anything to that effect, but it confirms that there was. Maybe that's where Sigstore is more. It's not so much about the building of the making of that bun. It's more of the identity of that process at that moment in time to say, all right, so when I bring you the bun, then it's a case of Lewis got you the bun because you can see the receipt. But then if a bun, again, we don't want it to be that the bun has got terrible stuff in it, but that's where that trust is implicit. You see me, and then you're like, I trust you, Lewis. Would you agree with that one, Zach? Sorry, I'm
Yeah. And the difference between the sort of real life and the digital world is it's much easier to fake a receipt in the digital world.
Zach says the image is this.
Yeah. Perfect.
What he says it is.
Yeah.
It's what. Yeah. And then Sigstore signs it.
I'll pause you for a second. What I then do is I basically, we can try another analogy. I think of Sigstore as like the DMV.
Okay.
So I'm going to go to the DMV. I'm going to show them my passport. I've authenticated with the DMV. Now the DMV is going to issue a driver's license with my name and what does my signature look like on it?
Okay.
And then I'm going to put the same signature on that little letter or that little receipt.
Relate that back to this.
So the idea is that I'm going to put some kind of signature on that document that we produced. Someone
Zach.
eventually is going to check that signature. Yeah, it's a scribble. It's not a beautiful thing. Yep, perfect.
Yeah.
Yep. Someone needs to check that signature, and then they need to say, okay, the signatures match, but whose signature is this? So Sigstore will give me something like a driver's license that says, if you see this signature, it belongs to Zach.
Okay. This is great. Okay, so the image is this.
Yep.
It's the image.
Yep.
And then it's signed Z.A. Zach.
That's pretty good. That would get through a check, I think.
And then Sigstore says if it's signed with Zach, then it's good.
Absolutely.
Okay. And then this is
sorry. Let me be pedantic one more time.
Yes.
Sigstore says
it's not one more time, but
if
okay.
it's signed with Zach, that is Zack Newman's signature. So if the signature looks like that, it's Zach's signature.
And that's what Sigstore is doing.
Right. They're making no claim about, like, Sigstore is not weighing in on whether that claim I made is true or not. It's just saying that I said it. And this is kind of what a real life notary will do, right? You'll sign a document in front of a notary, and the notary's got their stamp, and their stamp says, yes, in fact, it was Zach who signed this document. And that's the job of the notary. The notary doesn't say the claims in the document are true. It just says this is who signed it. Yeah. So that's perfect. That's exactly what we wind up with at the end.
Excellent. And then in the end, we have what we need is the image, and it's paired with the Sigstore.
That's a certificate.
Yeah. Okay. Yeah. This is a Sigstore certificate. What's this? How does this relate to real life?
That's our attestation.
This is the attestation.
Yep. And then the image now is a subject of the attestation.
Subject.
Yep, perfect.
All right. This is great. Thank you for going over it again.
Yeah, no, and it's really important to get this right. And I think one of the key lessons here is that you actually are able to say more if you claim less. And what I mean by that is, if I wanted to build a service to verify that a container was good, and then have that service vouch for containers, I don't know where to begin doing that.
Yeah.
But I can build a service that says, hey, someone convinced me that they were Lewis, and then that person who convinced me they were Lewis showed me this public key too. And you can let the sort of clients and the verifiers make their own inferences from that and make their own decisions about who to trust. It's actually a much more feasible system to build, and lets us actually make some powerful things that approximate this image is good. But by being more specific about what we mean when we say the image is good, we can actually make it. We can actually make that system.
And by being more specific, we're being more specific about who we're trusting to say it's good.
Exactly.
Like we're just basically decoupling what good is from the process of verification.
Exactly. And so the word I would use is probably policy. Like, what is your policy for accepting an artifact, a container image?
Policy feels like maybe a can of worms, or I do want to capture that. But before we do, I'm kind of, the logistics of this, I'm not quite done. My mental model is not quite there. And that is what, like, this, like, we're verifying trust in a container image. So presumably this is getting pushed to a registry, and therefore that image in the registry can be trusted. Like, how are all three artifacts bundled together so that the image is pulled, or like, what does this look like in its end state sitting in a registry for me as a consumer?
Yeah, that's a great question. And this gets to the kind of logistics, right? From a theoretical perspective, it doesn't matter. I could print these out and mail them to you, and you could type them into your computer of the same bytes, and you could do that verification. Obviously, from a real life perspective, it does matter. And so the tooling that we use in Sigstore will go ahead and stick, so that image is in the registry. We'll actually go ahead and stick that attestation and that certificate also into the registry as well, kind of alongside the container image. And it's kind of a hack. It's kind of a hack how we do that. So we can get into that or not get into that as desired. But there's a new feature in OCI that basically lets you attach things to a container image, and that's what we're doing.
So all three artifacts exist together in the registry, and they're coupled up as one thing, and it's OCI compliant.
Yeah, or rather, the image still looks exactly like it used to, but you can ask the registry, hey, are there any attachments on this image? And the registry will point you at those other documents.
So yeah, the container register, the image references the other two artifacts.
Yeah. Okay,
and so as a consumer, if I don't care about signing things, I can just pull the image and not even care that it's pointing at these other two. But then, and then if I am consuming, and if I'm consuming and I want to verify it's signed, is that something I need to do through the Sigstore ecosystem? Or I'm pretty sure Harvard does it. Like, are there other tools that I do that with, I guess?
Yeah, so anybody can do this same verification process. So it depends on like what you're trying to do. So you could imagine doing this from a Kubernetes admission controller. You could imagine doing it from the registry.
Okay.
You could imagine doing it from the command line, manually, and all of these are supported. So I'm going to use, the word verifier interchangeably for all of these scenarios.
Okay. Cool. So it can be pulled without verifying, or it can be pulled with a verifier. And there are lots of flavors of verifier.
Yep.
Okay, cool. All right. Do you want to talk about policy? Should I?
We can come back to policy, because I think
Okay.
I'd like to revisit quickly this paradox of short-lived certificates and long-lived artifacts.
Okay.
But before we do, just because I think it's one thing just to state, because we've focused purely on containers at this moment with that image and that last point, and then it's just to say that it doesn't just have to be containers here. It's the case of, it could be a Git commit, for instance. So you can sign a Git commit at this moment in time. If you set up, and I hope you have, if you're using GitHub, your SSH key, then you can sign commits quite easily with that. But also you could use Sigstore to be able to sign your Git commits, which could then verify yourself again against, ironically, GitHub or Google or another auth provider, again, just to verify yourself. And this signing process that Zach's just gone through, that same process happens for this different binary, essentially. But it could also be a blob. It could be a binary itself. These things that we're signing, and again, this is all just about building up trust at that stage. And you put it quite eloquently as well, Whitney, just to say, well, do I need to validate this? And then that takes us all the way back to the past. It's a case of, well, you didn't have the option to validate this in the past necessarily, because we didn't have what we've been discussing. You can validate this, and not everyone would potentially want to validate it. That's cool. We're all ourselves. We all live differently. Great for that. But if we go back to that food analogy, if you had a food allergy, so if you're allergic to peanuts or shellfish, when you go to a restaurant, your experience is a bit different to someone else. You don't just sit down and say, I'll order this, please. You'll first of all say, I have an allergy. Please, can you make sure that there's no trace of peanut in there or no trace of shellfish? When it comes to these artifacts that we're shipping, it's a case of, if we're going into highly regulated environments, back to that example of when I used to work in a bank as a developer, when we're looking there, it's not just as simple as, yes, we all trust this, but we need to build this up. And finally, just to add one other point to this, because that's the basis of it. If we're just using a snapshot of a code that we've verified, and then it's taken so much time and effort to do so, then over time, we're going to get CVEs. We're going to have 0 days. We're going to have issues that we learn with that. But if we can adopt to utilize new code, and we can use tools such as this to be able to imply trust, so that we can say, this is coming from a trusted organization. This is coming, we've seen the processes, we've seen their audits. When that builds up that trust, then it's going to help our security team say, we're more likely to use this. So I hope I haven't taken us too far back, but I'll pass back to Zach at this moment.
Yeah, so, no, that's all right. Sorry.
What I captured while you're saying that was that the images can be verified as part of the pooling process from the registry, but also there can be many types of artifacts, many types of verifying tools, and many types of verifying strategies.
Absolutely.
So it's not limited to this one. Yeah,
Absolutely.
Great. Excellent. And trust and assumptions. It all comes down to trust and assumptions.
Absolutely.
Yes. All right. So let's talk more about the ephemeral nature of the certificates. And maybe now that we have this diagram drawn out, we can talk about what's ephemeral and what we're trusting here. Yeah.
So this goes back to that difference in sort of the needs of public key infrastructure for browsing the web and for verifying long-lived artifacts. When I am, connecting to Twitch right now, I'm doing that at a moment in time. And so when Twitch gets its certificate from the certificate authority, that's going to have some quote unquote validity period. What is the dates between which this is valid? And so it'll say, something like, okay, starting on March 1st, ending on April 1st, or like 3 months is typical. And so that works because all that needs to happen is, the website operator goes and renews their certificate between, now and when it expires a month from now. And, they can cut over and they can have overlapping validity periods. And then, customer or like clients, what do they check? They check, I'm going to look at my watch. Does the time on my watch match the time in the certificate? So that's another thing that goes in the certificate is like an expiry date, basically. So that doesn't work for the long-lived artifacts necessarily, because if the artifacts expire, then that means they might expire because before, like they might still be good, but go ahead and expire anyway, and then I have to go back and re-sign them, and if I forget to re-sign them, prod goes down. Like that's really what we're trying to avoid. So what we do here is we say, well, the lifetime of the certificate isn't really about how long is the claim in the certificate valid, or the claim in the attestation valid. The lifetime of the certificate is much more about when did the signing happen. So what you can do is you can attach for that one-time use key. I only need to use it for the next, say 10 minutes. So when I get that certificate, it's actually going to say, it's valid between 12:25 p.m. and 12:35 p.m. Yep, and so the certificates are really short-lived in that sense, and this is fine. I have no use for it as the signer. I have no use for it 10 minutes from now, and this is really nice because it means even if somehow someone I didn't clear my memory and some attacker got it, or whatever happened, they're not going to be able to do anything with it because we're going to check that the signature happened at the right time. And for that, we need a new service.
They don't need to be renewed, and they're only valid for a very short window.
Yeah.
That makes sense?
Yep, absolutely.
Okay.
So, yeah, so there's one more, sorry?
Yeah, and you're saying there's a whole new service that's introduced as part of this idea?
Yeah, absolutely. So there's one more step in the verification procedure. In addition to checking that the certificate was signed by Fulcio, I'm also going to check that the signature got time-stamped by a different service called Rekor, R-E-K-O-R. And so what
Wait,
yeah.
I'm missing a key piece. Who's doing the verification right now?
Hypothetical future verifier, so Harbor or when you're pulling the image.
Okay.
But weeks
so
from
the
now,
verifier. Okay. So the verifier is verifying. Cool. So I'm gonna put that here. When verified, verifier is looking at two things. One is for this CA, this Fulcio. What did you say?
Dealer's choice. I typically say Fulcio.
Fulcio. Verifier is checking two things. So just these two things. Signed by Fulcio.
Yeah.
And what are they checking? Are they checking just all of these things together, or the Sigstore certificate specifically?
Yeah, so the Sigstore certificate will have a time in it, like an expiration date.
And that's what's getting the Sigstore certificate. Also, what's getting signed by Fulcio.
Yeah. Yes.
Okay. Okay, thank you. Signed by Fulcio, and we're checking that it is the timestamp is within the timestamp of validity within the validity window.
Yeah. So maybe a shortcut for that is signed at the right time.
I like that.
Yeah.
Cool. Yeah, that makes so much sense. So instead of it always needed to be valid, it was signed when it was valid, and then therefore, cool. I love it.
And then if you want to open the can of worms just for a millisecond, if you want expiration, that's a policy question. And so you address that at the policy layer. But it has nothing to do with the expiration of the certificates themselves.
Cool. I'm happy to open the policy can of worms. I just wanted to make sure we closed some other can of worms before we did.
Yeah, exactly.
We have John seeking a policy. This can of worms policy, certainly 100%. I hadn't realized you could do can of worms with emoji. That's nice. Excellent. So can we before we move on, can we talk about how the ephemeral certificate plays into this story?
Yep.
Now that we have it all drawn out.
Yeah, so there's one more box to draw, and I think it's little and it'll fit.
Okay.
but basically, there's what's called a timestamp, and so Rekor, that new service we were talking about, is going to basically timestamp our attestation.
Rekor.
Okay. It's from the Greek, Rekor.
Oh, of course. It's
everything in the I think Fulcio is maybe Latin. I don't speak either, so.
and adds a timestamp to the
attestation.
Okay.
And the important thing is that the timestamp goes over the signature part of the attestation.
Adds a timestamp to the signature of the attestation.
Yeah.
Cool. Excellent. So Zach, 11:11, 10:10.
Yeah. I would maybe draw it. Yeah. Oh yeah, we can cram it in there. Perfect. Yeah.
And really it needs a date and stuff too.
Yeah.
10:10. Yeah, whatever. Rekor. Rekor does this.
Yep.
And it's really only in the attestation. I just got excited.
Yeah. There is a time in the certificate, which is kind of like an expiry time as well. And those have to be compatible.
And then Fulcio is in here signing it. Yeah. Great. Cool. All right. So now we're going to talk about how the ephemeral certificate plays into this story.
Yeah. Yeah. I mean, once we have the timestamps, then the certificate can be only valid for a really short period of time. If our verifier a couple weeks from now goes and they check the time that the signature happened at, and that was before the certificate expires, then you're in pretty good shape. It's not like an old leaked key. Nothing. No funny business happened.
That makes a lot of sense. So the actual PKI certificate is issued for the attestation, and then that's used to make the Sigstore certificate. Is that true?
The key pair in the certificate is used to sign the key pair in the Sigstore certificate is used to sign the attestation. And then
then it's gone forever.
We get that signature timestamped, and then we have to get all that information to the verifier.
Okay. Where's how much space do I have? Not enough. Okay. I'll figure this out. Key pair used to sign the Sigstore certificate.
Used to sign the attestation.
The attestation. Oh God.
Yeah. It's a lot to keep track, and it's all really subtle too. It took me a long time to get used to all of the signatures flying around.
Yeah, and so from working with people with this as well, these are difficult things to get your mind around, and this aspect, because as Zach's been alluding to, this isn't part of the build process. Essentially, this is a way of identifying trust to things that are happening. So this isn't necessarily muscle that you use quite often. This is going into a bit of a different direction.
Right. The hope is that all of these details, though they're quite complicated, can be totally hidden from you. All you have to, ideally, the end user doesn't have to think anything, and then some signing protections get built into their package manager, to their container registry, etc. And it just happens magically for free in the background. So this is all for your edification.
I love it, and yeah, I'm enjoying it very much, and I think it is a wonderful point that you don't have to worry, but if you are concerned, this is a lot of fun.
Right, and again,
like
we
I
wanna
love
go into
knowing how
trust.
things work. Yeah.
Why trust this system? It's much easier to trust something if you understand how it works and what it's doing.
That's true. We had a similar episode for cloud native build packs where it's just like all you do is run a command and then it builds like your from source code, and then but like what's actually happening behind the scenes is kind of not so, just like this.
Yeah.
In a great way. Mm-hmm. Cool.
This whole presentation could have been 2 lines of bash, but we don't have to do anything.
Yeah, no, and that's actually true. Once you have the tools installed, it's, Cosign, sign, my container image. Your browser pops up. You click login with my Google account or whatever, and then it just does all the rest in the background. And then you can type Cosign verify my container image. You pass a flag to say make sure Lewis used his Gmail account to sign this thing, and then it just happens. So yeah, really 2 lines of bash. 1 to sign, 1 to verify.
And if I could use parallels to Kubernetes for a moment. So when I got started with Kubernetes, I didn't really know much about networking, and I learned about Kubernetes services. And so I started with Kubernetes services and I worked my way to understand networking. And it's a similar basis to that in that with Sigstore, this is a way that we can build the trust with identity. We've gone through the history of this. We've gone through the problems. And again, the complexity of that problem also breeds that this is why we have to have a thorough solution, and it has to be rigid. It has to be like this. But as an end user, you don't have to have this pain. Yeah.
Difficult to understand, easy to use.
But it's standing on the shoulders of giants yet again. It's just basically, you don't need to go through a whole security program. You don't need to understand every edge case scenario. But the people who have worked with this, and this is open source as well. So this isn't just an opinionated viewpoint from a single group. This is industry-wide as part of the OpenSSF. These are the best practices that were put in place. Yeah.
All right.
On the ephemeral certificates as well, I don't know if this will potentially help just in case, but the ephemeral certificate isn't just, the ephemeral certificate is essentially a child of another trusted certificate. So even though we're saying it's ephemeral and it's throwaway, it's coming from a secure place so that we can trust it. It isn't just this random certificate that we're just making randomly elsewhere. It's a child, and it goes back to you shared the new kind of a trust root. It's a child of that trust root, and so then that's how we can trust these certificates, even though they're short-lived.
That's brilliant. And you always think of as a certificate chain always verifying that bottom layer, but it's fascinating and smart to use the certificate chain to verify 1 layer up from the bottom layer and get rid of that bottom layer. I love it. Yes.
And it was, and as well with Rekor, for example, it's based on a Merkle tree, which then has similarities with Git. And I once had, when I joined ChainGuard, Zach went through that with me, and it was such an amazing time learning so much from Zach. But again, it's, and I think Luke Hines as well. So Luke Hines, give Luke a mention. He said this in a number of talks about Sigstore as well. And it's this basis of this bringing the right tools together to achieve this goal. And so this is, again, I think he mentioned about doing this from his shed in Bristol in the UK during lockdown and so forth. But it's this basis of, God, I've said it so many times, shoulders of giants. It's best practices, and it's using it. This isn't just a new, we think this might work. This is tried and tested solutions put into a position where now, with it becoming ubiquitous, with it becoming easy to use, and because it isn't just on container, like I said, it could be Git commits, it could be blobs. The more trust that we can put into this as well, the healthier that it'll make it. I don't know if you agree with that, Zach, as well, by the way.
Yeah.
And John says, great acknowledgement. The work is decades in the making. 2 lines of bash plus years of blood, sweat, and tears. And Lewis, you actually said something like where so much has come together to accomplish this goal. But then I realized our definition doesn't say a goal. What is the bottom line? What is the goal?
Yeah, the goal is secure software.
Easy. Right? Easy is part of it. Yeah.
And Sigstore tackles the sort of identity problem which is only a small component of secure software. But basically, when something, a container image, a binary comes to you, along with, a claim about why you should trust it, and then that claim is signed by someone you in fact do trust, then we can be, it's not perfect. It's not going to stop issues like, there's a new vulnerability in an open source library that no one, because that wasn't malicious, right? That vulnerability was just an accident. So we're not going to stop accidents, but we are going to stop is things coming from different actors than you thought they were coming from. I thought I was getting this package, from the NumPy maintainers, and in fact, it's Lewis trying to trick me, right?
Sorry about that, Zach.
The goal is what?
The goal
Knowing
is...
I'll try my attempt if you want, so you can. So I believe the goal is about understanding what we have control over. If we're pulling in dependencies from third parties, and that is open source, and it's a great thing to do, and it's what we're building the internet on. It's what we build on, is open source. But we also need to have trust. And so there are times in your life where you can't build all the software locally. You can't test everything locally. You need to have trust in place, and it's identifying where those trust boundaries are. So with this gives us a way that once we can identify a way to trust someone or something, whether it be that I trust this organization, I trust this person, I trust this identity. Once you get to that point, then that allows you, it's allowing you to have that secure way to be able to say, I do trust this. It was put in the comments earlier on about onion layer security. And as Zach mentioned a moment ago, this isn't a silver bullet. This isn't going to solve all your woes overnight, but this gives you something that you can build on. This is definitely one of those layers that you do need to have.
So the goal, I'm going with increased security by establishing trust.
Yeah.
What do you think about that?
Yeah, exactly. Establishing trust is I think really important here.
Because you had to trust me that Zach was as awesome as I said, and I think this will just show, I can see we've only been here for an hour and almost 45 minutes, and again, I think Zach's an amazing, wonderful human being, and the knowledge is phenomenal, and I equally to you, Whitney. So, but with that trust in, because we didn't really, 2 hours ago, we didn't all know each other as well as we do now, and but then we weren't. And it's to put ourselves in this position, we've got to have trust in each other to say, we're going to go on the internet, have this recorded, and it's going to be available for years and years to come. But if we didn't have this trust, and if we didn't share, then we wouldn't have been able to achieve it. So that's why trust is so important. Zach, I'm also trying to give you time to find a deck of cards, because we're getting done for false advertising here. See, I've done my magic trick of getting Zach to disappear. This is dad joke heaven. But, yeah.
So awesome. It's funny how there's so much to talk about. Sometimes it's easy to lose track of what's the one line goal. So I love that we step back and spelled it out. All right.
You got to stay till the end, but.
I love how you're using it as bait. Yes, you have to learn about policy now with us if you want to see the magic trick.
Yeah.
Assuming that's where we're going next.
One more detour along the way, I think. Okay. So one thing we've done here is we've made Sigstore an incredibly load-bearing part of our whole, trust ecosystem, right? If someone compromised Sigstore, they'd have control over everything, right? They can start impersonating anybody that they want. So what do we do about that? As much as I wish I could say we make Sigstore unhackable, unfortunately that's not, if we knew how to do that, we wouldn't have any of these problems in the first place. I don't think. And so the second best thing is make it accountable. And so what I mean by that is we basically make both of these components, Fulcio and Rekor, we make them show their work, right? We make them publish a log of all of the things that they do. So
Okay.
all the certificates that they issue, all of the timestamps that they issue.
So there's huge transparency there.
Yeah, and transparency is exactly the word that we use here. Exactly. We get this transparency property by forcing all of these actions to be public.
Okay. All right. Is that the long and the short of it, or is there more to it?
Yeah, that's the short of it. The
Okay.
long of it would be, now this complicates how we do our verification. One thing that you can do as part of this verification is you can also check that that certificate is in the public record. And you can check that the timestamp is in the public record. And what this does is it means that if Sigstore is cheating and they did something bad and then they didn't publish it, you're just not going to accept that. You're only going to accept certificates that are public, which basically forces everything that Sigstore does. It forces it out into the open. Because you could ask nicely for them to be nice and put everything in the public record, but if you don't require it, they could just hide any shenanigans.
That makes so much sense. So all of Sigstore's actions are public. So every time it makes any certificate, in addition, and the timestamps are all in the public record.
Yep.
So any verifier worth its salt would be checking that public record.
Absolutely.
As part of its verification process.
But also just be completely aware, because this is a first question that people ask then is, well, what about my image? What about my blob? What about my Git commit? Am I leaking that publicly? No, it's just that part of it. It is purely that. So the only unique identifier to you would be the email address. But again, other than that, it's, well, email address and what you use to authorize yourself, I presume. But yeah.
So what's a good way to capture that, Lewis? Like no proprietary information.
Maybe metadata only.
Okay. Yeah.
So yeah, and to use the earlier on analogy with DVL, is it DVLA? In the UK, we call it the DVLA, but I think you use one less letter than S.
The DMV, Department of Motor Vehicles.
Yeah, driving vehicle licenses. I don't know. Anyway, but it's this basis of, on that card, it just gives you enough information. It doesn't show you everything about my history. It doesn't show you my driving test. It doesn't tell you who my driving instructor was. It doesn't show you anything about my points or anything to that. But it just shows enough to be able to build that identity.
The trust. Yeah, that makes a lot of sense. Cool.
And there's one more point I'd like to make on the transparency component. The public record also is tamper-proof. And what I mean by that is, if I were an attacker, I could do something bad, stick it in the log, and then as soon as it had served its nefarious purpose, I could take it out of the log, and no one would ever be able to track me. Instead, what we do is we use some cryptographic tricks. And based on the space remaining on this whiteboard, I'm gonna say we'll table that for today. But we use some cryptographic tricks to enforce that anything that goes in the log never leaves. And the way that works is, I'm gonna go check on the log today. Sigstore is going to say, great, this is kind of the head of the log, and then I'm gonna come back tomorrow, and it's gonna say, great, we added a few new entries to the end, and it's going to cryptographically prove to me that all of the old entries are still there.
Cool. Excellent.
Cool. So then I think we can leave it at that, unless you have anything to add, Lewis.
We haven't mentioned Cosign, which is a tool that you might use to be able to sign containers. I think everything that we've gone through really identifies how this is a difficult problem, and we've gone, I would say we've grokked it into a level. So all this information, this isn't a cognitive load that you need to pass on to your team. This isn't a 2-hour video that you need to pass on to your team to say, right, we're using this now. This is a basis of just saying to you, to give you trust and just being able for you to be confident to say, we can trust Sigstore. We can use this to help trust. And also, the last thing I would just add to this as well, when you do share this, there's usually a focus, and this is completely fine. It's usually a focus on yourself. It's usually a focus of, well, what does this give us? And this isn't about yourself. This is about people who are consuming what artifacts you're creating. You're passing this trust. You're allowing those people in the future who are downloading or utilizing these artifacts, using the containers, using the blobs, is using it to be able to give them trust in what they are using. It's giving them the trust to be able to run with it. Yeah, I think that's me.
So what about Cosign? What's Cosign?
The point, I think, of Cosign is that there's a lot on this light board right now. We don't want, when I say the verifier is going to check this and they're going to check that, that doesn't mean you do each, like you, Whitney, would initiate
manually.
Each of those steps.
Yeah.
Manually. We bundle all of that complexity up into a simple, tool called Cosign, which is going to handle all of the steps in signing and all of the steps in verifying. And it's got a bunch of neat tricks that it does for containers in particular. For container signing is the name of the tool, and then it kind of evolved to a few more things.
Cool. Tool that handles container signing and verifying.
Yep. It can play other tricks as well, but I think that's a great summary.
Nothing ever is as simple as we write it on the board, but excellent. Cool. So we've talked about 3 tools that are just like that are useful as part of Sigstore.
Mm-hmm.
Excellent.
All right. So then maybe we do finally open up that can of worms, unless there's anything we want to address.
Let's see.
Let's go for worms. Let's go for it.
Yeah, and so I'll also cover a related topic, which is like, how are people actually using this? Are people actually using this? And I think these are kind of the same question, because you really, like, this is a building block, and the needs of a bank, to take one example, are going to be different from the needs of an open source ecosystem, right? Like these are very different organizations, very different individuals involved in the organization, sometimes overlap, but and so, like, if I'm a company, I can require that all of my employees carry an ID card or something like that. If I'm NPM or PyPI, one of these open source package repositories, I can't really require that of people. I can maybe recommend it. I can maybe, in some cases, PyPI did a really great initiative to kind of roll out 2-factor auth on a lot of the most popular packages, and I think it's possible that they'd extend that in the future to encompass even more people. But we want this to be a building block that you can use to address the needs of your organization, because the needs of every organization and ecosystem are totally different.
That makes a lot of sense.
And so that's the policy question, right? So the policy question is, we've given you with Sigstore a tool for letting people say things and checking who said them.
Yep.
The policy question is, who needs to have said what for me to trust something?
Yeah. How can Sigstore be adapted for different use cases?
Yep, absolutely.
Okay.
Yep. Yeah. And again, you're always going to start by asking who needs to have said what. For instance, I gave an example earlier, and it was a while ago, so I'll repeat it. But npm, so the JavaScript Node.js package repository, saw a lot of these attacks where there was an open source project on GitHub, and then someone uploaded malware to npm, and it did not match what was on GitHub. So they said, can we prevent just that kind of attack? We don't have to solve the world right now. But can we prevent just that kind of attack? And there's an accepted proposal in NPM to do exactly that, to require that when you publish your NPM package, it comes along with a note from a trusted build environment. So like Circle CI, Travis CI, GitHub Actions. It comes with a note that says, I built this from this, Git repo. And so that is an example of a policy. I'm going to require, a build attestation is maybe the way you'd phrase that. And the policy is, for me to trust a package as it's uploaded to NPM, or clients can do this as well. For me to trust a package when I type npm, install, it needs to have an accompanying build attestation from a build service that I trust.
Okay.
So that's one example of a policy, and Sigstore enables enforcing that policy.
Okay. I love that. I think I want to have a more like a definition, a more general definition of a policy, and then fill it in with the example.
I think who needs to have said what is I'll go back to that, and I think this fits that mold.
The basis of a policy is the question: who needs to have said what?
Yes, exactly.
Okay. And so, for example, a build attestation. And then a build attestation, if we spell it out for us lay people, what would that be?
Basically, I built this thing, whatever that thing is. So, I built square, I built triangle.
Okay.
I built triangle from this source or from this code.
Okay. From this source code.
Yep.
In this build environment?
Yes, exactly.
Cool. And then Sigstore can have a granular, like Sigstore is able to understand not just that something has been attested, but what has been attested, and that's where some of the more granular control.
And who said it too? And in this case, the build environment, though that's not really a person, is kind of the actor that we care about. So then that build environment is going to sign it, and that's a weird thing to conceptualize, right? Because it's not a person, but like it's an actor in the system, and so. If that build attestation, Sigstore enables signing that build attestation, right? I can create that build attestation right now on my laptop by typing it into a text file. What Sigstore lets us do is to say, hey, we have this attestation. Let's it can be signed, and then you can trust that the person who signed or the actor that signed it actually vouches for this attestation.
So Sigstore can verify the signer, but can Sigstore verify that the claims are true?
I don't think anyone can verify that the claims are true, right? The point of introducing the claim is to basically say, I'm going to take this person's word for it. Right. And so the idea is that I'm going to give, I'm going to witness or notarize a document that Lewis signs. And then it's up to you. Do you trust that Lewis would only sign a document with true facts in it? Or do you think he would lie to you?
Then the thing
You
I
don't
don't
have to answer
understand.
that, by the way.
The thing I don't understand is what Sigstore, like, if it's, what makes a build attestation instead of an attestation that just said, like, I kissed a skunk this morning? Like,
that would be a kissed a skunk attestation.
So it's more of a basis of, within this example, I want to ensure that it's going via the build service. The reason I want it to go via the build service is because we've built up security in our build service, external to Sigstore. And we've made sure that it's hardened. We've made sure that it's difficult to attack compared to someone's laptop. So if I built something on my laptop, there's lots of dependencies on here. I'm on my home network. There's lots of things that could potentially go wrong. So that claim is happening at that stage inside that build service in this example. And we're saying with this claim that it's happening at this moment in time. The identity that we have, if we're using Circle CI, for example, or let's say GitHub Actions, the GitHub action, the identity in there would be, I'm trusting GitHub. And so GitHub then trusts, GitHub is saying to me, if you trust me, you can trust that this machine identity is the GitHub action identity. So from that basis, I can say, well, I do trust GitHub, and I'm going to trust that this claim of it ran at this time on this build server. Then I can use that claim then to attest that it's happened here. So
okay. So Sigstore is still only verifying the author of the attestation.
Correct.
But do you tell Sigstore which authors to trust more than
Not even who to trust. You rely on Sigstore to say, because I trust Sigstore, I know that in fact Lewis did say this. And then I get to make my own judgments. That's the policy about whether Lewis saying something is sufficient for me to trust it. Because if I know Lewis is a liar, maybe I don't trust that artifact. But if I have a good relationship with Lewis, as I do, then in fact, I will take that signed claim from Lewis and I say, yeah, okay, great. Then I am happy to run this on my production environment.
So, and let's just take that. First of all, thank you for that, Zach, and I needed that today. But let's also just take that back, just all the way back to the other side of the screen when we're saying, how do we identify these people? So it's like utilizing either Google, where you got multi-factor authentication, GitHub, where you got multi-factor authentication, so that when we know that we're issuing via this identity, then that's given us trust. That's where our trust is building. So that identity is strong. Yeah.
So the policy part comes into, like, apparently a type of attestation can be signed by a certain person that you define in your policy, a certain person or entity that you define in your policy.
So,
yeah. Sorry.
Yeah. I was just going to, and I'll do my lights level before. If we're going back to our driving licenses, in the UK, we have our date of births on there, and that's usually used to get into nightclubs. And so that is attesting that I am who I am, and it's got my date of birth, which is my claim. Now, the policy in the UK is that I need to be 18 or over to be able to enter the nightclub. So that's a policy in the UK. In the US, it might be different, or in regards to alcohol, where I need to be 21 or over. So that's the policy, so different. And this is, so we got different policies because it's up to whoever is consuming me in this instance. Weird things to say, but it's on this basis of that they can identify me. It identifies my claim to my age, and it's up to them then to whether they're going to trust this, and then are they going to let me in based on my claim. And so that's where I see the omission.
So the policy here is to trust Lewis to make a build attestation.
Yeah. Yeah, in practice, it would usually be like trust GitHub Actions. But if I really wanted all of the packages on NPM to go through Lewis's laptop, we could do that too.
Yeah, I hear you. Am I still on the board? I don't know. It's getting, oh yeah, we are. Cool. A Fuel Snowball is asking if it's a policy trash can. It's a policy can of worms. Come on. I even wrote can of worms.
I got it earlier. I thought it was great, and yes.
Thank you. Thank you.
It's okay. Your joke went totally over my head earlier in the comments, so I think we're even now.
Well, so is there anything else you want to add right at this step? If you have some little, I can fit in like little nuggets of wisdom. I feel like you had a couple good like sayings that I didn't capture in the moment, that if you can reconjure them now.
Oh, that's tough to do on demand.
Yeah.
I'll buy Lewis maybe some time to think about that, and we can revisit the question that came
at the top.
Earlier at the top.
Mm-hmm.
So OpenAI, which is the company behind GPT and all of that, had a little bug, which is actually extremely bad for privacy, where I would log in and I could see total strangers, like the titles of the conversations that they had with ChatGPT. So you log into ChatGPT, you say new conversation, you give that a title, and then you start typing things to and from ChatGPT. So like this could be sensitive, right? Not that I endorse using GPT to diagnose yourself with medical issues, but like I could have said like, conversation to figure out, why I have this weird rash, right? Could have been the title of my conversation, and that would get totally exposed to a random stranger. And you could imagine other, that's something that people rightfully expect to be private. So this caused a big hullabaloo in the news. And then Sam Altman, who I believe is the CEO of OpenAI, went on Twitter and said, well, what happened was we were relying on some open source library. That library had a bug in it. And that bug is why we had this privacy issue. And I think there was a lot of reaction to that, where people said, that sounds like you making excuses, right? Like trying to throw under the bus some, possibly, volunteer open source maintainer who just did something in their spare time. Now your many billion-dollar company exposes a bunch of private user information, and you're trying to put it on this like volunteer effort. And so it's caused, I think, a little bit of a controversy there. And so I think the question is just get your thoughts on. So I can tell you, Sigstore is not going to prevent that kind of an issue, right? Nowhere in here did we come up with a magical algorithm that can verify that code is bug-free. If we did, I wouldn't be here. I would be on a Caribbean island somewhere on my yacht, right? Like that's kind of a holy grail, and I think something we're not going to really get to in any of our lifetimes.
Yeah.
So, sorry.
It's definitely a dangerous precedent to be like, well, our product's not security because of a library that we imported, and therefore we're not liable. Then that'll cause a mess.
Right. And a lot of this hasn't been really tested in court. But if you read any of these open source licenses that folks publish libraries under, they all have this phrase in it, without warranty. This software product or library or whatever it is presented without warranty. And it basically says, I'm giving this to you. I'm putting it out there in the open. What you do with it is not my fault. And that's the license under which these companies are using this software. And so that appears to be the legal precedent. Now there's some a lot of work in this US presidential administration on trying to say, well, we've kind of let companies off the hook for a long time when they got hacked. We let open source maintainers off the hook because they say no warranty. and then why does anyone have any incentive to actually try to make their systems secure? And so the current presidential administration is experimenting with proposing, rolling out policies, not these kinds of policies, but legal policies around liability for software that you're consuming, and saying like, well, like, okay, maybe, we can come up with something reasonable where if you're paying a company for a license and then that's why it breaks, you could, like, they're the one who's liable. But if it's free and that's, the relationship you have with the maintainer is you just downloaded something off the internet, they're not at fault. So I think of this class of bug as absolutely a software supply chain security problem. It's different, right, than the problem of getting something malicious or getting something from someone different than what you expected. But it's absolutely the same class where, like, I downloaded some software, included it in my application, and because of that software, not because of software that I wrote, I've been compromised.
Wonderful. Thank you for that. Do you have any nuggets you want to hide on the board, Lewis? Or the last thing we're going to do to close out the show, well, two things. The first one is I'm going to recap everything y'all have taught me today to make sure that we have a clear understanding of everything. But I wanted to see, do you want me to add anything to the board, Lewis, before I do that?
No, I think the board is fantastic in itself. This is also, going through this, it helps me understand more about, it can be tough to get started with these things, but the way that I see this now is invaluable. In talking about ChatGPT there, I haven't looked into it myself, but the thinking that I have now after using Sigstore is that, well, with using ChatGPT, where is this data models coming from and who is authorizing them? Because there's a risk, I'd say, where it's a case of if these data models have been corrupted, or if I put in a base image for a Docker file that I've actually owned, and then ChatGPT recommends me using this base image, and I put my trust into ChatGPT, what happens there? And this isn't a case of we don't all need to go away now and make tinfoil hats and then just wait for everything to blow over. But the basis of this is, I see the value with Sigstore, and I see the value that it will build. And I still think we will push forward now with Sigstore, and I can see how this can build trust. For everything that we've done, it is very simple to implement. It's very simple to get started. And this isn't putting any more cognitive load onto our already stretched areas. In using this now, it helps us improve our posture for the future. So I hope I've said enough. There might be nuggets somewhere in there. But like I said, I think the main thing is at the start, it's just, I'm a firm believer nowadays that it's best to get the conversation started. It's best to write a line of documentation and ask someone to review it to get their opinion, not just to have it held in your head. And it's the same with security. I don't think you should be waiting for someone else to come and say, maybe we should be more secure. I think it's important that when you see something that doesn't feel right or doesn't look right, or you think, actually, this might not work out well, I think it's important that we improve and harden our systems, our industry, because you can go on Hacking News most weeks and then you can see something else is going wrong in the world. So we just need to start putting hardening in place. And this isn't a silver bullet, but this definitely helps us push forward.
Absolutely. All right, I'm going to jump in on this recap. Let's see how we did. So the world before Sigstore, people weren't using all available security software, and that's because it was really hard to implement and hard to understand and hard to use. So because of that, assumptions are being made that software suppliers are who they say they are, and those software that's built on top of other software is making assumptions about the underlying software. So Sigstore assigns identity to actors in a system with the goal of increasing security by establishing trust. So those actors can be both people and processes. So this assists with key distribution. And when I say key, we're talking about keys in a PKI, a private key infrastructure system. Key distribution, key management, and the logistics of managing and distributing signatures. Before we jump into everything, it's important to reiterate, this is difficult to understand, but it's really easy to implement and use, which is actually one of the problems we're solving here. Is like, it was hard before, so people weren't doing it. Sigstore aims to make it an easy user experience. So, so Sigstore uses digital identity providers that are already in place, first of all. So in doing so, we use Gmail as an example or GitHub as an example. And so it can do that again with both humans and with processes, humans and robots. So Zach can get a Sigstore certificate by authenticating with Gmail or GitHub. Additionally, GitHub Actions, a specific action, can get a Sigstore certificate with which identifies the workload also. So 2 examples of that. And then Sigstore does this. The automation, I think, is important to mention because it is what underlies it being easy to use. The fact that all this is automated and not manual. But then we had to get into like, what does it mean to sign a digital artifact? Like all of this is, the trust is built because the artifacts are signed. But then what does it mean to sign an artifact? So an attestation makes a claim about the digital artifact, usually the trustworthiness of the origin, and then the signature verifies the attestation. So for an artifact to be signed, there's an attestation, and then there's a Sigstore certificate that signs the attestation. And that's called the signature, or that's what it means for an artifact to be signed. So to get into that a little more, one thing that's really cool about Sigstore is that the PKI, the public key infrastructure signature that it's using is ephemeral. So the private and public key pair is made just to sign the certificate, and then it's thrown away. So then you don't need to manage the key. The certs don't need to be renewed. And they're actually only valid for a very short window, and the signature happens within that short window. And then when a verifier is verifying that something is signed, one of the things it's verifying is whether that signature happened in that short window. So there's a few different like sub-projects of Sigstore that we talked about. So there's the Fulcio, which is the CA and signature, and then the Rekor that's adding the timestamp to the signature of the attestation. So to jump ahead a bit, when a verifier is verifying, they're verifying both that timestamp and that the Sigstore certificate is signed by Fulcio in particular. So to help us wrap our head around this, we drew a picture and talked about it at length. So Zach makes an image, and then Zach would make an attestation that this image is the image that I made. And then Zach was signed his attestation. And then Rekor will add a timestamp to that signature, right? And then Sigstore makes a certificate that says if that attestation is signed by Zach, then that is indeed signed by Zach. Like whatever Zach says is true is what Zach says is true. It's not saying anything about the actual truth of Zach's statement, but it is saying that if you trust Zach, you can trust that Zach signed this attestation. So in practice, the way these are consumed is that all three, if it's a container image, then all three artifacts exist in the registry. And then the image, it's an OCI compliant image, and in the metadata, it points to the 2 other artifacts. So if you want to consume this image without verifying that it was signed, you absolutely can. But if you do want to verify it's signed with one of many verifiers that we didn't really get into, you can do that, and you can see those additional, the attestation and the Sigstore certificate, and then verify that it's a good one. So the images can be verified as part of the pooling process, but there are many types of artifacts, all of which can be signed. There are many types of verifying tools and many types of verifying strategies. So yeah, this is great. So then the question is, why do you trust Sigstore? And if you trust Sigstore, the big reason is transparency. So all Sigstore actions are public. So every time it signs something, it is a public thing. So you can check that the Sigstore certificate and timestamp are both in the public record, and that should be the part of the verifying process. So, but you don't need to worry that your proprietary information is in the public record. It has metadata only. And then, the verifiers check the public record. It's also important to note that the public record is tamper-proof, which is done with cryptography tricks. So then we talked about one more tool besides Rekor and Fulcio. We talked about Cosign. That's a tool that handles containers, specifically container signing and verifying. And then we opened this, we've just barely opened a can of worms about policies. So with Sigstore, you can create policies that basically answers the question like who needs to have said what in order. So the example we had was there's a build attestation that says that Lewis says that I built this artifact from the source code in this build environment. Then the policy is to trust Lewis to make that a build attestation. But if someone else tries to make that attestation, we wouldn't trust it according to this policy. So again, Sigstore is only verifying the author of the attestation. It doesn't verify any actual claims. I think that's everything. Is that everything? Yeah. Great job. Great job, y'all. So I have 2 things left. One is we need to see a magic trick. Should I make you big on the screen?
Oh, man.
Are you ready? Yeah.
I can too.
Bam.
So I gotta get on a chair to be had. I got my desk in stand mode. Okay. So
I'll do a drum roll.
Regular deck of cards. You're gonna have to trust me on that. Look at this card. This is your card. It was the top card on the deck, the 7 of hearts. I'm gonna put it back down on the deck. Put that 7 of hearts right in the middle. Put it back all the way in. Lewis is gonna run Cosign sign, and then all of a sudden, boom, it's back on top.
Oh, wow! I trust nothing. I trust nothing. Zero trust. All right, I'm putting. This has been so much fun, y'all. Thank you so much for coming and sharing your time and expertise with us. The way we close out a show, Zach, since you haven't watched one before, is we dance at the end. I'm going to replay the intro music and we're going to dance together. Thank you so much, everyone who came and hung out today and everyone who watches the recording. I love how ready y'all are. Let me pull this through. Here we go. Goodbye, friends. Yeah, y'all are awesome.